All right, so let's continue on. And so now we're going to look at the piecewise functions. So at first, we're just going to evaluate these at these specific values. Um, shouldn't really be all that tough. The hardest part is just figuring out which one to plug it into. But other than that, that's it's really not supposed to be all that challenging. So right here it's telling us to do f of 5, and so you got to figure out what parameters it falls into. And so it's going to fall into the third one right here because 5 is greater than 4. So you're going to plug it in here. So you're going to get 10 minus 2 times 5. So you end up with 10 minus 10. We end up with 0. So we get a 0 there. Next one is negative 2. And so you're trying to decide which one between these two, but it should be the middle one because negative 2 is greater than or equal to negative 2, but it's also less than or equal to 4. So it's squeezed between those two numbers, and then equality indicates that we include negative 2 as part of this set. So let's see, we're going to have 1/2 times negative 2, and then we'll add 5 to that result. So negative 1 plus 5 is 4. So we'll go ahead and put a 4 right there. And then the last one is negative 5, which would fall into the first category because negative 5 is less than negative 2. So let's see, we're going to get negative 5 times negative 5 minus 8. So 25 minus 8, which is 17. So 17 right there. All right. Okay, so moving on. It's going to be kind of a continuation, except we're going to graph these. So we're still dealing with piecewise functions, but we're going to graph them. And so, all right, so to graph the first one, we only want to graph it when x is less than or equal to 0. Second one, we'll only graph when x is greater than 0. So we'll kind of color code this. So I'll do this one in blue. So basically, we'll call this y1 for the first equation. So there we go. And so we'll make a little table of values. You always want to include the value that it kind of bumps up against. So we're bumping up against 0, and it is included. So if you want to, you can put yourself a little closed dot that, yes, this value will be included. And so when you plug in values, you're going to multiply it by 1/2. So you probably want to pick numbers that multiply by 1/2 nicely, and that's going to be even numbers like 2 and 4. If you use 3, it's fine. 1, it's fine. You're just going to get fractions, and not a big deal. You'll still get the right answer. So let's see. We're going to multiply this by 1/2. So 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 4 is 2. So we'll go ahead and plot this. So at 0, 0, we're going to have a closed circle. Oh, yeah. I'm tripping. These need to be less than 0. So let's just, sorry, sorry about that. So we'll go ahead and it just changes. If I use negative 2, I get negative 1, negative 4, I get negative 2. Sorry about that. I'm sure some of y'all were saying, no, don't do that. You're doing it wrong. But okay, we fixed that. So let's see, negative 2, negative 1, negative 4, negative 2. And we'll go ahead and draw this. And we'll put an arrow on the end because it just indicates that the function continues past the graph, right? Then the second one, let's see, we'll do in red right here. So we'll call this one y sub 2 equals 3. And so really, x is not going to have a bearing on this because basically what's going on is x has a coefficient of 0. So whatever you plug in for x, it doesn't really change anything. You're just going to keep getting 3 when we create our table. Now, 0 is not included, and if you want to, you can put a little open circle next to it because you do want to include it on the graph, okay? Even though 0 is not included, because values like, 0.1 are going to be included, 0.01 are going to be included, and so those will actually be closed circles, right? So you want to get as close to, basically you don't want to leave any values behind. So we're going to start at 0, 3, and I'm going to do an open circle, but then see all those points that come after it are included. So anyways, that's what that'll indicate for us. So we'll pick another value that's a little bit bigger, something greater than 0. So I don't know, let's go 3. So when I plug in 3, I get 3 again. 3, I get 3. And we'll go ahead and draw our line right here. Okay, very good. Okay, so you'll have something very similar to this on the exam, and it'll actually be multiple choice. So you'll have a couple different graphs to choose from. So you'll want to choose the right graph given the piecewise equation. And then there's going to be a part 2 that basically says, okay, now what is the range of your graph? Actually, I guess on the test what happens is I give you the graph and you pick, I guess the multiple choice will be what piecewise function matches to it. But anyways, so the second part will be like, okay, now look at your graph and decide what the range is. And so if you look at this, the y values go down indefinitely. So they're going to go down from negative infinity and come all the way up and stop at 0. And we get to include 0. And then union, you also get to include the y value of 3 because 3 is part of the range up here. So 3. All right, so that's it for piecewise functions. All right, let's do a couple more. So next is going to be the difference quotient, and so this formula will be given to you. So don't worry about memorizing it, just make sure you know how to apply it properly. And so we'll kind of color code this as I work through this. So this first part's telling me to substitute x plus h into my function. So this is going to give me x plus h squared. Okay, then minus 4 times x plus h, and then plus 2. Okay, and then in blue, basically subtract f of x, which basically I'm going to subtract this whole thing right here. So minus parentheses x squared minus 4x plus 2. So you got to put it in parentheses or else it's not going to work out for you. And then all divided by h. Okay, so what we'll do is we'll start with squaring this. So that should give us x squared plus 2xh plus h squared. Then we'll distribute the 4x here, so minus 4x minus 4h. Don't forget about your plus 2 right there. And then, let's see, we'll do this in a different color. So then here we'll distribute this. So this will give us a minus x squared, a plus 4x, and then a plus 2. And then this is all divided by h. And so what's going to happen with this, and what happens with all the ones we've kind of looked at in this course, is that a lot of the stuff cancels out, probably more than half of it. So let's see. So right here you've got an x squared and a minus x squared. So we'll go ahead and cancel those out. Okay. Then let's see, what else do we have? We've got a minus 4x and a plus 4x. So we'll go ahead and cancel that out. And then we have, oh, once again, you probably saw I made a little mistake right there. Let's see, this should be a minus 2. And so that's kind of nice about these, though, is that you can catch yourself pretty easily. Because like I said, typically most of this stuff cancels out. So if you end up with something that doesn't kind of reduce nicely, you can kind of look back and so you can see that I made a little mistake right there. Okay, so let's go ahead. So we've got the plus 2 minus 2 that we'll go ahead and cancel out. So that leaves us with these 3 parts right here. So we're left with 2xh plus h squared and then minus 4h all divided by h. And so now you're going to divide each one of these individually by h. So when you divide the first one by h, it leaves you with a 2x. When you divide the middle by h, that reduces that down to just a plus h. And when you divide this last one by h, it just leaves you with a minus 4. And that's what we're looking at right there. Okay, I'm going to go ahead and finish. Might as well just go, well, yeah, I'll go ahead and finish this page off here. Okay, so right here we're doing the algebra function, so we're going to add, subtract, multiply, and divide. On the division, it's really easy. You just need to list any restrictive values you come across. So adding them together, all they're basically saying is take the f of x and add it with g of x. That's what that notation means. It just means add them together. So we're going to take x squared plus 3x, and we are going to add 4x minus 5 with that. So when you look at this, let's see, I've only got that x squared. Combine the x's, that'll give me 7x, and then I've got the minus 5, and that's it. That is what we're looking for right there. That's it. Okay, the next one, it's very similar, except that we're going to subtract the g of x function from f of x. So let's see, we end up with, we start with x squared plus 3x, and then we're going to subtract the g of x function, which you got to put parentheses around and distribute the minus sign here. So we're going to want to go ahead and distribute that. So let's see, we end up with x squared plus 3x, then this becomes minus 4x, and that minus 5 actually turns to a plus 5. And then once again in the middle, we can kind of clean this up a little bit. And so what we end up with is x squared minus x, and then plus 5 right up there once I simplify those like terms. Okay, the next part you're going to multiply. So you're going to take the f of x function and multiply it to the g of x function. And what we're going to have to do here is FOIL. So I'm going to go ahead and write it down, and then I'll scroll up a little bit. So let's see. So we're going to have x squared plus 3x, and we're going to multiply that with 4x minus 5. Okay, so this isn't too bad. We've done this before. We're just foiling. So x squared times 4x, that's going to be 4x to the third. X squared times minus 5 is going to be minus 5x squared. Then 3x times 4x is a positive 12x squared. And then 3x times minus 5 is going to be minus 15x. And then once again, we do end up with some like terms in the middle that we'll go ahead and combine. And so going up to put our answer up here. So let's see, we get 4x cubed plus 7x squared, and then minus 15x. There you go. Okay, last one, you just divide them, and there's really not much to it. You just write it down. Basically, you're going to be graded probably more on finding those restricted values, which isn't too difficult. So let's see, the f function is x squared plus 3x, and you're supposed to divide it by the g function, which is 4x minus 5. Now what's going on here is you want to find any x values that would cause you to divide by 0 and exclude them. So you look at your denominator and you ask yourself, is there anything that would make this equal 0? And this is a linear equation, so it's pretty simple to solve. You can do it in 2 steps. So we'll go ahead and add 5. So 4x equals 5. And then divide by 4. And so we get x equals 5 over 4. So that is the excluded value. So list any excluded values. 5 over 4 would be the excluded value. If you were to plug it in, what would happen is you'd have some value on top and divide by 0, which is not good. All right, so I'll go ahead and make another video for the last part.